Good afternoon, everyone, and welcome to today's webinar on the role of new technologies in occupational safety and health. My name is Luz Marin. I am a professor in the Department of Safety Science and Environmental Engineering at Indiana University of Pennsylvania. So in this era where workplace dynamics are rapidly evolving, technology is not just changing how we work, it's also transforming how we keep workers safe. So today we will explore how these innovations are transforming workplace safety and how we can use them to anticipate for potential injuries, to monitor worker fatigues, and the exposure to hazardous conditions in real time. So with this presentation, we will go with this presentation for about 40 minutes, and then we will have a time after for questions and answers. If you have a question that maybe we cannot go in detail during our webinar, so we will be posting these questions later on. So let's start first with just some of the numbers in terms of the statistics in safety and health. So these numbers are from the Bureau of Labor Statistics, and they just paint a picture of workplace safety in the United States. Let's share a little bit of the information here. So first, let's acknowledge that human cost, and in 2022, so we have the report of 5,488 workers that they lost their lives on the job. This is one death every 96 minutes. This represents a 5.7% increase from 2021, showing that we are moving in the prevention efforts are not giving the expected results. But beyond the immeasurable human toll, there are also an economic impact. The National Safety Council estimates that in 2022 alone, workplace injuries cost our economy $167 billion. And the breakdown of this just amount is just they estimate that about 51 billion in lost wages and productivity, 38 billion in medical expenses, 54 billion in administrative costs, and 50 billion in employers and insurance costs, and finally about 9 billion in vehicle damage and fire losses. So what else we can say here? So what is the major categories of workplace fatalities? This pattern helps us to understand where technology can have a greatest impact. So we have transportation and vehicle safety. So while transportation incidents have decreased to 0.6 from pre-pandemic levels, we still saw 1,369 roadway fatalities in 2022 and a concerning 9.3 increase from 2021. So we have another category here that is full slips and trips with 165 fatalities in 2022. That represent or that increase that includes 81% from falls to lower levels. Also, we have in terms of other hazard, we have in an unintentional injury by person, so 791 fatal events. So this include violence, the different type of violence between just strange to workers, or just worker to worker, worker to supervisor, or other types of violence according to NIOSH classification. So we also have contact with objects and equipment, 738 events, exposure to harmful substances, 586 events, and we have here fires and explosions, 100 events, so this is fatalities in the workplace, and heat stress, 43 fatalities in 2002. So this is an increase, especially with heat-related deaths. This is an increase from 36 from 2021 to 43 this year. So in terms of musculoskeletal disorders, just zoom in this information. So we have that in 2022, musculoskeletal disorders, they accounted for nearly 30% of all workplace injuries. These injuries are often caused by repetitive motion, overexertion, and awkward posture. Over the 2021-2022 period, there were about 500,000 workplace musculoskeletal disorders that they result in at least one day away from work. But also other more severe injuries, like they result in back pain and tendonitis or carpal tunnel syndrome. So there are the records show 246,000 cases, which result in an average of 12 days away from work for affected employees. So musculoskeletal disorders, they are not only expensive, so they are not only can generate a lot of the days away from work, but they are also very expensive. So the Liberty Mutual Workplace Safety Index, they estimate that that musculoskeletal disorder, they are costing employers around 15.2 billion annually in direct costs like medical care and lost wages. So let's move now into fatalities by group, occupational groups. So we know that in this picture, so we can identify that basically farming, fishing, and forestry, so they have the highest rate of fatalities with 23.5 fatalities per 100,000 full-time equivalent workers. Then is followed by transportation and material movement, and then we have construction and extraction occupations. So these are the top 3 occupational groups with the highest rate of fatalities. So let's see now and move into just this, a little bit of the evolution, a very brief analysis of the evolution of workplace safety. And I want to start here very early. So we have this is a just very rush review. So we have the Industrial Revolution, so this is called Industry 1.0, that is the steam age. So before steam power, so workplace safety was limited to human capabilities. The introduction of steam-powered machinery in late 18th century brought an unprecedented productivity, but also new safety challenges. Workers, they face unfamiliar risk factors from powerful machines that they never encountered before. Then we have the Industrial Revolution 2.0. So what happened at this point? It's called the electricity era. So the arrival of electricity in the 19th century was transformative, not only because it allowed more distributed power system, but it also led to more compact and efficient machinery. This era saw the first systematic approach to workplace safety, as electrical hazard required new safety protocols and standards. Then we have the Industrial Revolution 3.0. That is just like the introduction of the assembly lines and electronics. This is the automation age. So this just basically in the 20th century, so brought assembly lines and electronics that fundamentally changed the workplace safety. Automation reduced direct human exposure to hazardous tasks, while electronics control just like systems or interlocks, or just they were able to reduce some kind of hazards in the workplace. So then now we can move into the 21st century, and that what some people call the Industry 4.0. But it's just what is happening here. So we have just like the digital integration of technologies, we have the Internet of the Things, sensors monitoring workplace conditions in real time. So now it's the integration of the digital technology with systems physical systems in the workplace, right? So patterns to predict artificial intelligence that detects patterns to predict potential accidents, smart sensors detecting hazardous conditions before they become dangerous. So it's at this point, so it's just like the Industry 4.0 that we are going to discuss all these elements of the new technology in safety and health. So when we talk about technologies in the workplace, so we can classify this technology into different categories. So I am going to use here one in terms of the functions of this technology. So you can see the source, just the reference here for this classification. So in this classification, so we are using, as I mentioned, the function. And in this classification, so there are 4 functions or main functions identified for this technology in safety and health. So one function is about monitoring, supporting, training, and tracking. So when we talk about monitoring, so we are talking about something that maybe we are familiar with, like fitness trackers, so smart rings, or smart glasses, patches, sensors that are attached to the body, smart clothing, or sometimes implantable wearables. So this kind of monitoring, this kind of technology allowed us to monitor and control vital parameters of workers. Right? So in this case, for example, we can identify or we can get information about heart rate, blood pressure, body temperature, brain activities. And this information gives the organization, right, could be the safety manager or the supervisor, and the worker himself or herself, an idea of the readiness to conduct the job from a physical point of view. Right? So this is what we try to do, or what is tried to do with these monitors. So the other thing is monitoring of environmental parameters of the workplace. So we can use sensors to identify or to track temperature at the workplace, atmospheric pressure, level of radiation. So information that allows the organization to control the overall environmental situation at the factory and prevent emergencies or just like routine events. The next group here is supporting. And in supporting, so basically we have technology that is increasing the physical capability of workers. And here is when we have exoskeletons, that they could help us to lift and control the position of the body when we are lifting heavy objects. So that is just the next function. And then we have training. And obviously this is training workers or supervisors and managers on conditions that they can find in the workplace. So we use here virtual reality, just like headsets, that we can just use to allow workers to experience the situations that they could just face in the workplace, but from a safe perspective. Right? So they can just experience, they can put their hands into the operating points in the virtual reality, so but they are not going to be just affected. And then we have tracking, and tracking is another one. So it's just like we can talk about the smart bracelets or the smart clothes that they also allow to monitoring on the location of workers. So to identify, for example, if we have workers in an area when we have moving machinery, or we have workers when special activities that we need to have empty areas to perform the task. So these are the 4 functions that in which we can use technology. So now let's see a little bit. So this is just like in general, so we're going to discuss some of these technologies. So I have classified these technologies into wearable safety technology, right? That they are used to measure to continuous and objective measurement of posture and movement or other variables. So computer vision and artificial intelligence, we have exoskeletons and assistive devices, and virtual and augmented reality. So I'm going to move into some of these technologies and with examples, so how we can use it in the workplace. So let's start with these wearable technologies. And many of you are already wearing just sophisticated safety devices right now, right? So I am talking about your Apple Watches or your Fitbits or other smartwatches that we can use. So these devices, these everyday devices, they use the same core technologies that we are using now in the workplace. Think about your smartwatch. Already monitors your heart rate. Your fitness tracker counts your steps and analyzes your movement. Your device can detect if you have been sitting or standing for too long, or actually if you have been on the phone just for too long. So many smartphones, they can even measure environmental factors like noise levels or altitude. So what we are doing in the workplace safety is taking these familiar technologies and adapting them for specific occupational needs. For example, so you use your Apple Watch to set if you need to sit after a long period of standing or if you need to stand after a long period of sitting. So in the same way, wearables, they can alert workers about poor posture or repetitive motions or conditions outside or external conditions that could affect them. So also when just a phone can detect if you have fallen and call emergency services in the workplace, so we can identify dangerous environments, the dangerous atmospheres that just alert the safety system in the organization. So the same technology that tracks your running pace in your fitness app is being used to monitor workers' movement patterns in hazardous activities. This means that workers are already familiar with many aspects of wearable technology, and this could make the adoption of the workplace technology smooth. So we can see here, what you see here in this picture, so this is the reference of this picture. So what you can see here is just like different kind of sensors that we can use, wearable sensors, to monitor different aspects. So these are small but very powerful tools that they are transforming how we are monitoring unprotected workers in the real time. So think of wearable devices as tiny personal safety guardians. Despite their compact size, they pack an impressive array of capabilities. They have advanced sensors that continuously monitoring the environment. They have sensors that they analyze the data in real time. They are able to storage variables and identify patterns. And this makes and what really makes these devices remarkable is their ability to create a comprehensive picture of workplace safety by measuring different parameters simultaneously. So we can, for example, monitor physiological aspects, heart rate, blood pressure, so I mentioned that before, tracking of stress levels, body temperature, so when people they are working on outdoors under heavy or under extreme temperatures. These sensors, they can also monitor hydration levels for outdoors workers too. So they can also identify or measure the respiration rate to detect fatigue. They also can identify oxygen saturation for confined spaces or analyze, just like conduct a kinematic analysis to prevent ergonomic related injuries. So these equipment are also able to identify patterns, to identify risky behaviors like repeated motion and monitoring to prevent strain. So there are some of these wearables here. Let's talk a little bit of these ones. So what we have here. So let's talk about these smart insoles. This is what you see here, right? So think of this of a highly sophisticated version of your comfort insoles, those that you might put in your work boots. But this is just like with multiple sensors and what they are doing. So what makes these smart insoles special? So these are devices that essentially they are a pressure mapping system. So if you see here some points here in this picture, They pass the information to your phone or your laptop, and you can evaluate here. So with these sensors, so you can evaluate just like information or just like variables regarding to how the weight or your body weight is distributed, and also what are the walking patterns, the standing posture, the pressure points on your feet, your balance, and your stability. So why is this important? So why is it important to measure this? Think about like in the construction industry that we have different surfaces, right? So that you can work on concrete or mud, or you can work in just like very unstable surfaces. So if we are able to identify or having the information so that allowed us to understand under which surfaces workers they have less stability or less balance, so we can anticipate injuries, right? And we can provide just additional controls. So the technology, the insole is not, in this case, is not in itself the control, right? So but you can anticipate that if you in your construction site you are going to have just most of the time certain type of surface, so maybe you need to think about just guardrails or other elements in certain areas that could reduce workers livelihood of fall down because the instability or the lack of balance that this kind of surface they cause. So we can just like, as I mentioned, identify a worker they are standing incorrectly, detect weight distribution problems that could lead to back issues, monitor prolonged standing patterns that might cause fatigue, so identify unstable walking patterns in different surfaces, and alert workers when they have potential unstable position. So day one, with this, we can also identify fatigue, and we can just like identify when a worker's movement is showing signs of exhaustion in order to identify when is the right time to provide breaks. Practical applications of this kind of a wearable is just early detection of potential for risk, reduction in fatigue-related incident, and improve workplace design. As I mentioned, just like introduce controls, improve the conditions to minimize the likelihood of injuries or incidents in the workplace. So what else we have here? So now this is another one. This is called is a movement monitor. It's similar to the previous one. So this is just like this is a kind of a fitness tracker that is able to identify just the gait parameters. So this device, this sensor, measures the walking speed, the step frequency, and the step length and symmetry. And this is important, so particularly when people they are just doing manual material handling and there are different surfaces. So why is this? So why these particular parameters? Because these parameters they can use to estimate, to anticipate the risk of falling under certain surfaces. Pretty much what I was explaining before. So we use this, what we have used currently here in our department. So we just finished one study that we evaluate just the gait parameters and their different surfaces for construction, so construction workers. So this is important. So this allows just to, is attached to the low back, and we can identify the different parameters. So that's another one. So what else we can have here? So when workers they use power tools or they operate vibrating machinery, so maybe they don't realize about the very dangerous conditions that they are exposed. So you know that exposure, long-term exposure to hand-arm vibration may result in the hand-arm vibration syndrome, right? So this technology, so this is a watch that you can see here. This technology tracks vibration magnitude, the intensity of the vibration, the exposure duration, and the frequency of the vibration. And they also, this is something that is important, is the cumulative vibration too. So you can identify, so by just like the worker using this just watch, they can identify the accumulated daily exposure, right? So they will be able here to see if this parameter is above of the recommended limit or above the actual limit, and maybe just being able to reduce the exposure time. So that's another one. This is very important, especially with vibration, that usually is no hazard that we just follow very often. So what else we have here? So we have just like it's very interesting. So you measuring vibration sometimes is difficult in the workplace because the equipment, but I think that having this kind of just like wearable is a very simple way just to have an idea the exposure that workers they have. So then we have this, that this is very important. So I mentioned at the beginning that there are 43 heat-related fatalities in 2022. So we have here a wearable. That's a wearable to for heat stress. So you see, you know that ear temperature is one of the variables to identify heat. So the body temperature, basically. So this is a wearable that use multiple sensors to just to provide critical variables in terms of just identify the body variables, how they are changed when we are exposed to extreme temperatures, right? So in this case, so you can the worker can use it and you can monitor, and the system is going to send just a signal to the worker just when they are close to the limit. So in that case, it just like alerts the worker that they is approaching to the limit values, so they can just remove from the work environment that is causing this problem. So that is important. So this is very important. I mentioned so 43 fatalities, heat-related fatalities in 2022. So this is another one that we can use for workers when they have to work during the summer or when they have to work in environments that are very or they are exposed to extreme temperatures. So let me move into the other part, so into just the exoskeleton as an assistive devices. And the exoskeleton, if you are not familiar with this concept or with this word, an exoskeleton is a wearable device that basically assists the movement, right? Assists human movement. So basically, some of these, just like we know that musculoskeletal disorders, they are many times associated with just like heavy lifting in the workplace. So the exoskeletons, they what they help is just to support the body just when we have to lift, and just through that support reduce the musculoskeletal disorders probability. So we have two types of exoskeleton. So what you are seeing here in this picture is one that is called a passive exoskeleton. So a passive exoskeleton is a wearable device that supports a user's posture of movement without the use of any power, right? So you don't see any power here. So basically, the passive exoskeleton use powered mechanisms like springs, dampers, or counterbalance forces to provide assistance. We cannot see here, but in this area, when I said autobox, in this area, so we have the different exoskeletons, right? So sorry, the different strings, so that we sprints, and we just like those are the ones that accumulate the energy, and these exoskeleton, they redirect the forces in the body, so they storage them and release them when they are needed. So they are used in this case, so you see this in the picture. So these are there are students in our lab, so they are using the exoskeleton to help to support the weight of this tool, right? This is an equipment that helps. This particular version that you are seeing here is one that helps the workers to support weight above the shoulder. So it's just like if you have the opportunity to test this exoskeleton, so it holds your arms on help to support the weight of your arms. So this is the kind of this is a exoskeleton. So electricians, plumbers, so this is something that they can use. So this is most of these exoskeletons. So we know that there are different anthropometric measurements for workers, but most of them just based on some just like adjustment, they are one size that fits to everybody. So you can just adjust it and just using from different kind of body sizes. So let's see. So we have here another one. So this is the powered exoskeleton. So these are a kind of mobile machines that they usually intend. They are trying to help people to with their movements, and they trigger powered system to increase the user's strength and endurance. That's basically what this equipment does. So you can see here in the picture. So they have here you can see just the motor here, and the person could just support, and this helps this worker to just apply more, so to increase their strength, so they don't have to apply the regular force that you need to move in this case this patient, right? The power exoskeletons, they can support each of the major points and with their associated muscles. They are typically designed to allow workers to exert much greater forces than when unassisted, and that increase their endurance. So this could be this could be helpful to perform tasks that they demand very high forces and some time, like heavy lifting, just when you need to work on just lifting in a difficult or a hazardous position, when you can work in certain tasks for a long period of time but not frequently. So those are tasks that the exoskeletons they help you. So we have here, so I want to see if so you can see this is again in the lab, so you can see just the students using wearing the exoskeleton, so to lift some task. This is just created in the environment, so this is a task, and this exoskeleton they have, this is a kind of vest that you are wearing here, and there are different sizes, so people from different body composition they can do it. So here, I want to see we can just power this.
Okay, so do that like 2 or 3 times. So it's not on right now. Alright, it's not doing anything. And what I want to do is just click it on real quick and then, alright, I'm going to go to 7.
So you can increase the power. And here in this one, so that I'm going to play here. So this is the student just showing or describing how he feels in terms of how the equipment is supporting his legs and his back.
Pushing my legs like this way, and like pushing my chest kind of. So I'm literally just hanging here. You can. I always tell them like when your boss leaves, you can take it.
So what you see here is just like he's in this, just by keeping this posture, he's not just making too much force from his back, right? So this is what he's doing, he's describing here. So these are kind of equipment that we can use. These are a little bit more expensive, so we use it in the lab just for research, but they are available for companies just to use in commercial, so for commercial use. Let me go here. So now we have the virtual augmented reality. So this is another dose. So we went to sensor, exoskeleton, and now the virtual augmented reality. So that's basically here. So we have it's just like computer generated. So this is a different type. So we have computer generated digital environment, and can be in this, so through the virtual reality, so people they can experience and interact with the environment as the environment were real, right? So this condition were real. So through this headset, the virtual reality, so you can you can just use existent apps, existing environments, or you can create some of these environments, just customize these environments for your condition. So this is a good way, for example, to train workers or even supervisors and managers, just because you are able to immerse them into the experience, so experience hazardous situation in a controlled and safe environment. Right? That's what we try to do. So as I mentioned, so you can find apps that they already have some of situations. So OSHA, they have some, I think that 1 or 2 apps, and it's like $15, so you can use it many times. And you can find other companies, just like real companies, just like using this or selling these kind of apps. And this is just examples. This is a project that we are conducting with the steel workers in Pittsburgh. So you can see here workers just using the wearables. So I'm going to play this video clip. This is a worker that he was playing with one of the apps, and he's taking just the some from a toolbox on tools and using it. So this is what I want that you guys see. So this is good in terms that you can train the workers in a safe environment. So if you make mistakes, nothing is going to happen, but technically you are going to get the information about the consequences of these mistakes or errors in the workplace.
Okay, look to your right and up, and you'll see where you're supposed to tie off to. That blue ring? Did it connect?
Yep.
Okay, I'm gonna read around. But I think there are
So here
little
he
like
just like moving
clues and
everything.
stuff that go along the way, like he found a screwdriver. Do any like
He's getting
comfortable with self and everything?
And look what he did. So and let me tell you a little bit about this environment. So he is working, so on the app, he is just working on a 20-story building. So what he did, when you see that he moved back here, so when he moved, let me see here. When he moved here, so he took a screwdriver from the toolbox, and what he did is that he just throw the screwdriver from the 20-story building, right? So we know that this is a dangerous condition. So what happened in the app?
But I bet you there's other things too we haven't noticed yet. Like
Do
he noticed there's
you want more Boston?
screwdrivers.
Or something. You know, like it says 3M science, body life, 3M.
Yeah.
So what happened in here is that he threw the screwdriver. So the app is telling him just that that was an unsafe act. So, and what happened is that immediately remove him from the 20-story building, put him on the ground, and tell him that he needs to go to training again in order to continue doing the task that he was doing, because he did an unsafe act. So that's the kind of things that you can, you can just try. So you can use in simulations. This is another way that you can work here. And these are just, like I said, these are just examples of different kind of activities. So this is just a brief review of some of the sensors and some of the exoskeleton, virtual reality. So today you can find a different kind of elements So to conclude, I would like to say that this technology and device, they are already offering several opportunities to maintain occupational safety and health in the workplace. So we should take advantage of them. But however, we shouldn't forget just the hierarchy of control. And this is why I am bringing this as my last slide in this presentation, because we need to be able, so employers, they need to identify and evaluate how they are going to reduce the risk factors in the workplace and keep a risk that is acceptable for everybody. So don't forget that just like elimination, so removing the physically removing the hazard from the work environment is the best option, is the most effective. So if this is not possible, we can just implement substitution, then engineering controls, that is just like isolating people from the hazard, and administrative control, that changing how the way people work, and finally just personal protective equipment that we know that is the least effective. Some of these technologies, they can be considered engineering controls. Some of them they be considered administrative controls, and some of them they also can be considered personal protective equipment. So we need to be very clear about this. We need to understand how they work and the limitations of this equipment I have, right? So you can find in the market so different kind of sensors to identify why these kind of sensors that identify that the worker is in a wrong area. That's fine, but we cannot forget about just like what is happening here. So why a worker is in a wrong area? So what is just moving the worker there? What is just like the driver from that worker to be in an area that is not allowed? So it's something that uh, we need to think about. So we cannot just rely only on the technology. So we need to understand that this is just technology is helping us to keep the work environments safer, but it's not replacing our, as a safety professional or employers, our just like ability to assess the entire work environment. So this is the review that I wanted to share with you. So now I'm going to conclude in this part, and we will be open to questions that you may have, or comments or suggestions. Thank you very much.